All right. So David Lightbown is next up. He is UX Director at the Technology Platform at Ubisoft Montréal. Please welcome David.
Thank you very much. You guys hear me? Good. All right, so that's it. My name is David Lightbown, UX Director for the TG Technology Group at Ubisoft Montreal. And the title of the talk is Hiding in Plain Sight, the untapped resource that is helping Ubisoft to make better tools. Now, this is a talk about tools development and tools used to make games. I'm going to link it back to game development, though, as well, and games UX. So I think that we can agree that one of the keys to helping, to getting better user experience for our games is iterations. So this diagram you'll recognize from the human-centered design specification, the ISO specification. Going through that loop, and every time we go through each iteration, we try to make the user experience better. But we could also say that better tools UX, better tools also help us to get more iterations. This diagram on the right, this gentleman in the back here may be familiar with it. Helping us to get through that gulf of execution and the gulf of evaluation. More times we can go through that without that kind of friction, the more iterations we can make, and better tools UX can help us do that. So we might also be able to argue, therefore, that better tools UX will help us to get better games UX. Now, this is a conference taking place in North Carolina. That's a picture of me, some point in the 80s. My grandparents are there, it's my sister and brother and my cousin. So Fayetteville in the 1980s, and who would know that this little kid here one day would grow up to work at Ubisoft in the technology group as UX experience director. And my role as UX director, I do a lot of different things. One of those things is to consult with the different game teams. So I'll help consult with the tools teams within those game teams to help them develop their tools to allow people to make content for those games. I'll also educate some of those tools teams and the technology group as well. We have about 250 tools developers in the TG group in Montreal. It's a pretty big team, a lot of people to kind of help them understand the value of user experience. So I do a workshop and different kinds of training as well. And also to evangelize the work that we're doing, kind of like what I'm doing today. So doing it externally, but also doing it internally. We have about 10,000 employees, so there's a lot of people to try to bring up to speed on the value of what we all know is a good technique and something that we want to do as much as possible. Here's the problem, though. The developers are essentially in control of everything when it comes to tools. So you can't tell them what to do. You can't push the idea on them. You have to pull them towards you. You have to convince them of the value. It's a very developer-centered kind of situation. What we want to try to do is move it more towards a user-centered sort of environment, trying to change the development ecosystem that we have within the company. Now, if you look at, say, Nielsen's corporate UX maturity scale, some of you guys may be familiar with this. You go from 1 to 8. When you're at level 1, hostility towards usability. You guys may have experienced this yourself, where people are not interested in watching the users use the tools. They don't want to change the way that they work. And that's how a lot of game development, because it's been like that for so long, you're changing techniques that have been in place for a long time, so why do people want to change? A lot of hostility. And through dedication the last couple of years and the work that I've been doing, building up a small team, we've been able to get ourselves to what I would consider to be a level 4 within the technology group. We do have a dedicated budget. Although it is sprinkled sort of sparsely around the company, the budget can be cut in any time. So we're really in that zone, and we're trying to get to level 5 now. For those of you who haven't read this, it's an interesting kind of scale to be aware of and to see where you yourself fit into this if you're working for a company. So what I'd like to talk to you about today is what are the ways that we can try to convince tools developers of the value of improving the user experience of our game tools. And this is the way that I've had a lot of success, is by using games to help developers understand the value of better tools UX. The things that they make themselves, that we make together, we kind of understand. And so by using examples from games, I'm able to speak in a language that tools developers who make games understand a bit better. I'm not talking about experiential or emotional games like, let's say, Flower or That Dragon Cancer. I'm talking more about games where speed and accuracy are important. Let's say like Dota or Counter-Strike. I want to try to use games that are sort of more in the esports sort of realm, so to speak, to explain some of these concepts and how we can try to make tools developers understand the value of making users more productive and more efficient. Not sure why my taskbar is down there. Okay, there we go. there are lots of different concepts that you might want to try to explain to a tools developer so they understand the value of these things. Some of these are a couple of examples. We're just going to talk about two different ones today. We're going to talk about trying to use games to explain the concept of chunking and use games to explain the concept of vision, perception, human vision. So here are the two ways we're going to do this. I'm going to show you examples of how you might be able to use RTS, real-time strategy games, to explain the concept of chunking. And then finally, we might use fighting games to explain the concept of vision. Let's start off by talking about RTS games and how they can help us to explain chunking. So this is Boxer. He's one of the most celebrated StarCraft players in history. Anybody else a StarCraft fan here? Anybody? Yeah? Oh, wow. That's great. Fantastic. So some of you guys might know Boxer already. Obviously, you know, multi-level champion, specifically in Brood War, although he did come back in the StarCraft 2 days and still beat everybody somehow. So when he was very popular, when he was very skilled in the Brood War days, you would see something like this. Boxer's opponent would send some units to his base. So you can see here a mix of a couple of units in the upper left-hand corner. And within a couple of seconds, he would build just enough units to be able to defend against what's coming towards him and not slow down his economy. And StarCraft is a game of momentum, and if you build too many units, you slow down your economy and you end up losing. So you have to build just enough units to defend against what your opponent is sending to you. And not only was he able to build just enough units very quickly, he's doing that at 5 different bases simultaneously at the same time, and doing that repeatedly against all of his opponents. He's very good, is what I'm trying to say. So how can that help us to explain the concept of chunking? Well, a lot of you guys, certainly in this room, I know I don't have to tell you about the Invisible Gorilla video. You guys have all probably seen it by this point. That research was done by these guys, Chabris and Simons. I think it's Chabris. And they did a lot of other research studies as well. One of the more interesting studies they did was a chess study in the 1990s. And this study, what they did is they gave the participants a piece of paper with different chess piece configurations. And they gave them 5 seconds to memorize those chess piece configurations. And then they took them away. And then they basically gave them the time to basically put that board back together from memory. So they had to remember what they saw for 5 seconds and then place all the pieces on that board. So who were the participants? Some of them were novice players who were just still learning how to play chess and had not played a lot of games. And they were also up against guys like this, Grandmaster Patrick Wolff, who had played thousands of games, at least. And what was really interesting, though, is this is, first of all, not a surprise that a Grandmaster would be way better than the novice players for some of those sheets he was asked to memorize. What was really interesting is that in other cases, he was just as good as the novice players. That seems kind of strange, doesn't it? Why would that be? Well, the games in which the Grandmaster was better were sheets that came from configurations that came from real games of chess. At a certain point of the game, they took a shot of that game, and that's what he was given. The games where he was equal were boards that were generated randomly by a computer, randomly generated pieces. Now, what's interesting about this is you start to understand why he may have done equally to the novice players, because there are implausible or impossible situations here. You can see here, it's impossible to have 2 white bishops on a dark square. It's impossible to have 2 kings side by side. So these would be things that Patrick would never have experienced in a game. So of course, when you hear him talk about how he was rebuilding the boards, you can watch the video on YouTube. It's interesting how he explains how he chunks all this information. There are lots of different configurations of pieces that he's seen many times before. So for example, this group of 4 pieces, he's probably seen that in hundreds of games. And he considers that as one chunk, while the novice players think of each of those pieces individually. So he's chunked the board into pieces. He would even chunk pieces that were not even touching each other because they're all related to, let's say, a checkmate position. It's very interesting to watch how he explains his chunking. So let's go back to our example with Boxer, go back to a video game example. So Boxer certainly has seen this chunk many times. In fact, this what's called a unit composition in StarCraft is so common. The flying units are called mutalisks. The ground units are called zerglings. This unit configuration is so common it even has a nickname. It's called mutiling. So it's a mutiling configuration. And so he's seen this group of units, and that's how he knows exactly what he's going to build to defend against it. Now, what would happen if we sent this towards Boxer's base? Now, this would be very, very unusual. It's like having the two white bishops on the dark square. It's impossible or implausible. First of all, a lot of these games are one-on-one. So one race versus one race. And this is a mix of Protoss and Zerg units. That wouldn't happen, first of all. Second of all, you have these units that are supposed to be long range in the front and a sort of a meat shield unit in the back, the Ultralisk. You would never do that. His opponents would never do that. And also, these are all ground units. So if you sent a flying unit against them, they have no defense against it. This sort of thing would be very unusual for Boxer to have chunked because he would have almost never seen it. So when you haven't chunked some of these unusual situations, it's hard to be able to react quickly. Now, how does that relate to game development tools and how we can use games to explain better user experience in tools to tools developers rather? Well, here's one example. When we work with color in a lot of content creation tools, we think about color as being defined by red, green, blue, 3 different values. Now, in the Adobe suite, you can see on the left and in the middle, we have Photoshop and Illustrator. The color green is represented typically by 0%, 100%, 0%, or 02550, 0FF0. Somebody is accustomed to seeing those 6 numbers, that 6 hexadecimal value, as one chunk in their brain. They've memorized that as meaning green. Now, Microsoft Blend here on the right uses a different model. Because in Visual Studio and in XAML, Blend, Visual Studio, they use alpha, red, green, blue. So to somebody who is chunked 00, FF00, meaning green, they look at this and they get confused. Is this red, 100% red, 0% green, 100% blue? What's the other 0 at the end? Is that alpha? I'm not sure. And what's extremely confusing is here at the top, RGBA, but then at the bottom, ARGB. So really hard for a user they can't basically apply the chunks that they've memorized in their brain in terms of color to this. They have to kind of rewire every time they work with it. Another example, position, rotation, scale. So we look at another set of tools here, Unity, where whenever we define the position of an object or the transform of an object, it's position, rotation, scale. And typically a new object is going to be 0 position, 0 rotation, 1 scale, 100%, 100%, 100%. So basically a cube would resemble that if you made it from scratch. Same thing in Maya, translate, rotate, scale, 0, 0, 0, 0, 0, 0, 1, 1, 1. And for some reason, Softimage flips this around. Scale, rotation, position. So again, that chunk that a 3D artist might have in their brain of 6 zeros and then 3 ones doesn't really apply to Softimage. So if they glance at this, especially if they're flipping between, let's say, Unity and Softimage, they can't apply the chunks that they've already set up in their brain of the sort of identity matrix being 6 zeros and 3 ones in the case of Softimage. So we want to try to avoid this sort of situation. So let's talk about some of the things that we've seen in our tools at Ubisoft and how we've tried to use games to explain this concept of chunking to tools developers so that they can avoid these sorts of issues. So in the case of Watch Dogs, one of the elements of the game, if you guys have seen it or you're familiar with the game, we have crowd behavior. So we have a lot of different AIs running around the city in Chicago. And we want them to react to what the player is doing. And so we have animators and developers who are building these sort of blend trees, these animation systems, so that when something happens, it's going to blend to a run or blend to a walk or a cower or defend yourself or whatever it is. So we have 2 different tools to do this. One is called the Move tool, which is for authoring these animations. And you can see here, let's say this is one animation clip, and we have a start frame, a late start frame if it blends in a little bit later, a safe cut frame if the animation ends. Where is it safe to cut out without having a pop, end frame, etc. Now the Move tool has this UI to help you see all those different values, the frame at which it's going to do these different things. And you set those different values so that one animation might have a better end frame or a cut frame than another. But when you debug, you have a totally different display here on the bottom. Okay, so this is for authoring. This is for debugging. So you can see here on the top left, the safe cut, let's say, is at frame 30. Bottom left, safe cut also 30, but different position, written differently, not in the same order. So that if you've built up a chunk, let's say, and you understand in your mind what 0, 10, 30, 50, 72 means because you've seen it many times, you can't apply that same chunk quite as easily to the UI on the bottom, right? Because it's not laid out in the same way. So what did we do? We developed a new tool called Dissect, which is for authoring and debugging animations in that engine. And so we designed this sort of one central representation of an animation node, and each of those different markers on there represent all those different concepts, the start frame, end frame, the cut, etc. And regardless of the situation, it always looks the same. It's the same colors, the same markers. And so here I can show you kind of what the tool looks like in action. What this tool allows you to do is to record your gameplay while you're playing, and then stop at any time and pause, and then scrub back. And so as you're scrubbing, you see the game stops and it starts to move backwards in time, and so you can help to catch bugs and find issues. So you can see here all of these nodes, the representation is the same. Whether you're authoring or whether you're debugging, visually looks the same, and I can go in and scrub the animation, and I can see all the different values. And if I have the order in which those little markers are placed, if I've sort of chunked the configuration of them for one node, I don't have to think of it in a different way when I look at it in the debug view. Whether I'm authoring or debugging, it's the same visual representation. And another example on Far Cry really quickly here. We had an asset browser that we were building. And you can see here on the top, we have, this is the folder view, the folder hierarchy. So we have a folder called world inside, man-made, shared inside bricks. And here on the bottom, we have an object and the path of that object. Now you can see here, man-made shared, the folder name, and man-made shared, the folder name, is not written exactly the same way, right? So as you guys know, probably ascenders and descenders in text, when we scan words, we quickly identify what they are based upon the general shape of the word. This makes it harder for somebody to go and access what that word man-made shared means in their brain. Why is it uppercase at the top? Well, we talked about having a developer-centered environment. This is so that the search code underneath runs faster. So I told them, guys, let's see what happens if you put uppercase. It took an extra 0.01 milliseconds. It was fine. So really easy fix. We made everything the same camel case as it was in the tool, so people are able to make the link between the folder names and the path name in the actual item itself. All right, so let's close up the how we can use RTS games to explain chunking and move on to how we can use fighting games to explain human vision and perception. So this is Sacco. He's a Japanese fighting game player. Any Street Fighter fans here as well? Okay, a lot less than StarCraft. This is disappointing. So he's one of the best known fighting game players in the world. Certainly one of the best Japanese esports athletes. So SteelSeries a couple of years ago released this product called the Sentry Eye Tracker and allowed you to take this product home and do eye tracking recording as sort of if you're an esports player and you want to improve your game. And as a part of promotion of this, they released a video of Sacco playing Street Fighter 4. Now, I want you to keep your eye on this white dot as he plays. And I want you to think about what is it that's significant about where he's looking while he's playing. What is it that's significant about where Sacco looks while he's playing Street Fighter 4? Now, while you ponder that question, I'm just going to go over a couple of things here. You guys are certainly familiar with saccades and fixations. A saccade is when our eye moves from one point to the next. Those are the orange lines. And a fixation is where our eye stops at a certain point and focuses and sort of absorbs in the information that we're seeing and interprets it in our brain. Our central vision is very sharp, but our peripheral vision is very blurry. Now, I've read some information that seems to suggest that our peripheral vision can be as low as, I think it's 3 pixels per foot out here. Movement is good, but resolution is very low. So at the center, we have very sharp resolution, but at the periphery, we don't. So let's imagine if Sacco is looking at Ken, he sees Ken, but Elena is not perfectly in focus. But if he looks at Helena, he sees Elena, but not Ken perfectly in focus. And also, as this is what novice players do, if you were able to eye track a novice player, they typically fixate on one, they saccade over to the other, fixate on one, saccade over to the other, back and forth and back and forth. So not only are they losing time by going saccading back and forth, but also their eyes are constantly refocusing. And so, you guys probably correctly assume, what is significant about watching Sacco with the eye tracking is that he always keeps his eye at the center, in the space between the two players. And this allows him to keep sort of a general view of both players at the same time. And what is he looking for? He's looking for if they are in startup, active, or recovery. For those who play Street Fighter, you know, the startup frames is where you might be able to interrupt your opponent. Active frames is where you want to stay away. That's when they're attacking. And then recovery frames is that's your opportunity to strike, when your opponent is defenseless. And so speaking of chunking, we talked about before, he has chunked all these different sorts of poses, these configurations over the millions or whatever, thousands of games that he's played. And because he's able to see both players and he's chunked that information right away, he's able to react. And that's what makes him a pro player. So how does that apply to game tools? Well, some of you may have read this article. It's a very well-known article on UX Matters about label placement. It's an older article, but it has some interesting ideas. What they did is they did some eye tracking tests on label placement. And what they found, at least in this article, what it suggests is that here you have three options: left-aligned, right-aligned, and top-aligned labels. And what they suggest in the article is that right-aligned and top-aligned, so the middle and the right ones here, label placement is the most efficient in regards to reducing saccades and also the amount of time spent fixating. So the most efficient placement of those labels. So we want to try to apply that knowledge to our tools as well. Now, if you look at some other examples here, the Unity Inspector uses left-aligned labels. So if I'm staring, for example, at my values, I'm not seeing my properties. And likewise, if I'm looking at my properties, I'm not seeing my values, exactly like the example we saw with Seiko. So as I'm putting my eye back and forth, again, lots of saccades to make my way back and forth between values and properties, values and properties. We want to try to reduce that for the users. If we look at Maya, for example, because they have right-aligned labels, I can stick my eye right in the center of the property grid here, the attribute editor rather, and then I can just guide my eye down the center and be able to soak in all the properties and their values at the same time. Now, how does that apply to our tools at Ubisoft? So for example, here we had this tool called the Mainframe BuildDB, which was for sysadmins to administer build machines for building the game. So we have, again, studios that are working together around the world. When somebody checks something in, we want to auto-build the game or auto-build the engine or whatever it is, so we always have the latest version. And so they set different paths for the different tools that are used to compile these different elements. But again, in this interface, you can see if I'm focusing on the properties, I can't see the values. We also have these little help bubbles, which are great to tell the users what these properties mean, but they have to move their eye all the way over. So again, we have a lot of saccades and fixations back and forth. And also really hard for us to make a link between the label and that little help bubble. So easy solution, right aligning the labels and putting those help bubbles right next to them. Really, really quick fix. It was done within a couple of hours by a developer. So again, but by using that example of Seiko and the eye tracking, it's easy to explain to somebody the value of doing this. So again, we can just keep our eye in the center, just like Maya, and glide the eye down to be able to absorb in all that information. And finally, Heroes of Might and Magic level editor. This is a level editor that I worked with the team out in Germany. So the level editor ships with the game. And you can see here, again, left-aligned labels. So we have the labels and the values. Again, our eyes are saccading back and forth and back and forth. Just one last note I'd like to talk about, because it kind of it goes against one of the recommendations of the article, but of course every situation is different. I believe that top-aligned labels were either recommended slightly more or gave slightly better results regarding compared to right-aligned labels. However, if you look at something like this from the Might and Magic level editor, when it comes to content creation tools, this is not a web form. We're not just putting in name, address, postal code, or zip code. There's a lot of data that we work with. So you'll see in a lot of content creation tools, because there's so much information in these user interfaces, and it's very dense, we prefer right-aligned labels, because if you start stacking things on top of each other, you can see there's a lot of dead and empty space here. So in our specific context, even though it's possible that they might test slightly better according to this article, we still prefer right-aligned labels. So again, you can see how you can glide your eye up and down, but you're going to require the scroll bars there. It's going to require you to scroll more as opposed to if you had just right-aligned labels. So that's it. That's how we can use fighting games to explain the concept of vision to tools developers. So I hope that you understand, or you've seen today, how you can make a connection between having better tools UX and through iteration can also help us to have better games UX. And if you're trying to explain to somebody or tools developer the value of better UX, well, you can try games to help developers understand the value of better tools UX. Thank you very much. I'd be happy to take questions. I know that my topic is not perfectly in line with what you guys are doing. I wrote a book also about UX and tools development. The title's down there at the bottom. So yeah, I'd be happy to take any questions if you guys have any. Thank you for saving me.
Yeah. How difficult was it to get Ubisoft to start doing this? Just like it.
Yeah, that's one thing I didn't mention when I talked about the, he who controls the compiler controls the universe. We have very resilient users who are just happy to work in games. They're so happy to work in games, they're willing to put up with lots of, I don't want to say abuse. They put up with a lot. Also, they also don't think it can be any better. So if somebody fixes undo, redo, they're very thankful for that. That shouldn't even be a question, right? The smallest little things, they're very appreciative of. Big things break, they don't say anything about it. So it was already like anything. There were a lot of quick wins that I could gain by coming on board. I was also fortunate that there were people who already were sort of sold on the idea, and they were able to kind of take me under their wing and help me get started. But it's been a couple years, and again, level 4, even that is within the TG group. Outside of TG, we're maybe like more level 1, 2, or 3. So it's still a long road, but we're getting there. Sure.
So working in mobile games, we have a lot of native tools that we've built in-house in our pipeline. How are some of the ways that you guys have, as a UX group, have either run tests or raised awareness on like creating better tools?
Okay. Test? Okay. So the question was, okay. How have we been able to raise awareness on the value, like the
yeah,
ROI
like on either like how much improvement time you're going to be able to make with you do these UX changes or
yeah, it can be expensive and complicated to really get actual hard numbers. I think for some people really they do understand once they sort of see and feel it, you get buy-in. I think one of the best things to do, and the most impactful things that I've done is just to bring developers to people's desks and watch them work. And right away they can see the before and after difference. You don't have to actually quantitatively measure it. Right. And it can be, in some ways it might even be, in some situations, more expensive to actually measure than the time that you might save. It depends upon the tool, obviously. If it's exponential, then that's a different thing. But we have done some quantitative studies where we're able to sort of calculate rough estimates of how much time reducing, closing a pop-up that takes 3 seconds, multiply that by X number of people. We have some pretty bad situations where we were able to get some very clear gains. But obviously, as you go, those gains start to peter off. But at the beginning, it's easy. But yeah, I think that through, like I said, the consulting work that I've done, evangelizing and presenting and that kind of thing, if a game designer says to me, I'm going to try to do this and I think it's going to be fun, nobody asks them to measure the fun. Yeah. If a programmer says, I'm going to try to use this algorithm, I never say, well, can you do algorithm A and B and then tell me which one's faster? Nobody ever asked them that. So I think we have to get to a point as, for me at least, people who try to improve the UX of our tools where people just sort of implicitly, through experience, through positive experiences they've had with us, they trust the work that we do in the same way that we trust other departments as well.
Cool. Thank you.
Thank you. That's it. Thank you very much.